a lifetime in repeat.
All right, so now we have our ball moving. So we're going to add the ability to have an arrow so you can see where your ball is going to go as a kind of a targeting system. So on BB10, just to use this as a reference, if you touch anywhere on the screen, grab and pull back, you'll see that they have an arrow that gets created, and then on top of the arrow they have this dashed line that gets longer the more you pull back. Pulling back more doesn't make your ball go any faster, but it does allow you to see a little farther where the arrow goes. We're going to start just with the line. If you want to add the arrow, you absolutely can, but for now we're going to start with just the line part. So kind of see how that goes, and let's get to it. So again, I like the particles and stuff. So one thing that I forgot to show you guys last time was how to actually save your scene. So what you want to do is in your assets folder, you want to right click and create a new folder and call this folder scenes. And then in here, before we go any further, go up to File, Save Scene, or you can hit Control S if you're on a Windows, Command S if you're on a Mac, and it'll ask you where you want to save your scene. So I'm going to save it in the Assets folder, inside Scenes, and I'm just going to call this Main. You can call it, Level 1, Paul, Frankie, whatever you want to call it. So now, when you leave, your scene is actually saved. Okay, so what we're going to do first here is we're going to focus in on the ball because the arrow we're going to make attached to the ball. So I'm going to click on the ball, and I'm going to right click when it's highlighted and go down to Create Empty. And this game object is now a child of the ball. It says it's at position transform over here, which is its position in the scene. It says it's at position 0, 0, 0, but the ball itself is at position -0.01, -3.84. So these coordinates here are in relation to the object it's a child of. So if I were to give this an x-coordinate of 1, it would move 1 unit not in world space, but 1 unit to the right of the ball. I want to keep this at 0, 0, 0 because I want that, that arrow to come from the center of the ball. So I'm just going to leave it 0, 0, 0. I'm going to rename it though. I'm going to call this arrow. All right. Now I'm going to add a component to this. And the component I'm going to add is called a line renderer. It's under rendering, I think. Oh, no, I'm just going to search for it. Line renderer. So what a line renderer does is it creates a line that draws straight out and goes in between 2 points. Now, before we can actually see the line renderer, I'm going to create a new material. So I'll go back into the Assets folder, into the Materials folder, and then I'm going to right click and I'm going to create, instead of creating a physics material, I'm just going to create a material. And you'll see this kind of sphere pop up. I'm going to call this line material, which is going to be the material that we attach to the line itself. Now you can see this turns kind of dark, and that's because it's expecting there to be a light in the scene. And if we're working in 2D, we don't need a light. So I'm going to change the shader from standard to one of the particle shaders, and I'm just going to use alpha blended, and I'm also going to change the tint color here to, I like blue and I like green, so I'm going to make this green, and I'll leave the transparency, the alpha value that you can kind of see as a white black line underneath it, I'll leave that alone for now. So if I go back to the arrow, it has a position in here for materials. And you can have more than one material. They kind of layer on top of each other. So you could have like a blue background and dots on top of it. For now, we're just going to do the blue. So I'm just going to pull this onto element 0. Or, yeah. There we go. I don't know why I didn't take it last time. Okay, so we have just that one. And now what we want to do is look at the positions here. So we want our positions to go, right now it goes from 0, 0, 0 to 0, 0, 1, which you wouldn't see in 2D mode because that uses a Z position. I want it to go from 0, 0, 0, which is the center of the ball, because that's 0, 0, 0 as far as the arrow is concerned. And I want to shoot it straight up a certain number of units. So I'm going to move it up let's say 6 units. Okay, that's certainly interesting. So a couple things first. We have the line renderer here that is super thick. The reason it's super thick is because it has its width set to 1. I'm going to set the width to 0.1. That's already better. The other problem is the line doesn't start until way the heck up here. And to fix that, we're going to change it from using world space. So just unclick that. And now the line is coming out of here. Now, you can kind of see the line here. It's just a plain rectangle. I'm going to change that a little bit here. I'm going to make it so that it isn't just a plain rectangle. And I'm going to do that with this width box right here. So I'm going to have it start out at 0. And then I'm going to add a key here, which is just a place that I can manipulate this curve. I'm going to have it go up to something big. And I had it start at 0 so that I can't see it behind that. And then I'm going to add another key at the end. It goes down. And I'll add a key in between. Okay. What did I do? I'll just move both of these up, I guess. Or this one up, and then I'll move this one down a bit. Yeah, that's what I wanted. I don't know why it didn't. Oh, it's super thin, that's why. Okay, so anyway. Now we've got our arrow here. Now, the problem is, if I just go into play mode here really quickly, and if I grab and pull in the scene, the arrow just stays in this one fixed position. We don't want that. So I'm going to control the arrow through code here. Sorry, I'm still middling with this. You could spend forever playing with this, but it's fine. Okay, so to control it through code, I'm going to go into MonoDevelop, and I'm going to open up the script that we had open before, which is the ball controller script. I'm going to create a new global variable, which is a reference to the arrow in the scene. And because it's a reference to an object that's in the game, it's called a game object. And I'm going to make this public so that I can assign it in the editor. And it's game object, and I'm just going to call it arrow. Okay. Now, the rest of this is all going to happen inside the mouse dragged method. Sorry. Okay. So last time we added this did drag equals true, and then we added some code just to say to move the arrow, and now we're going to actually move the arrow. So there's a few things that we need to do first. First, I'm going to turn the arrow on. So I'm going to say arrow.setActive. And then this needs to have a value passed in. You see here the summary, set active, it needs to have a Boolean value. Remember from last time, Booleans are true or false. So I want the arrow to be true. So I'm going to set it active by telling it that it's true. The next thing I'm going to do is I'm going to create a temporary mouse position. Because the mouse is going to be moving around in the scene, I want to store that kind of temporary position. So I'm going to say vector2 temp mouse position. And that's a temporary position because I don't want to overwrite the start position from up here, and I don't want to use the end position yet because I want to keep that kind of separate. So this is just kind of a temporary mouse position. This is going to be equal to a new vector2. And it's actually, no, it's not. It's going to be the same way that we got the mouse position up here. So I'm just going to copy this and then paste it down here. So camera.main.screen2worldPoint, and then whatever the position of the mouse is in the scene right now. Downsize this a little so you can see it better. Okay, so now let's talk about some stuff that I'm sure that everybody thought that their math teacher was lying when they said that they would use it later on. And let's talk about geometry, more specifically trigonometry. So what we want here is, I'm just going to kind of draw this a little bit bigger so you can see it. We've got our ball that is sitting on the ground. we have a position in the center that our arrow is coming out of. And so we're considering this to be 0 degrees, which is hard to think. You'd think 0 degrees would be over here. But in this case, as far as unity is concerned, 0 degrees is straight up. Okay? So what we want is we want this to rotate. So let's say that I'm pulling my mouse here. I want this to be rotated 180 degrees away from it in this direction. Okay? So in order to do that, I'm going to look at a right triangle that gets formed by the mouse drag. So if I drag here, we talked last time how this has two components, an x component and a y component. So the y component is down here and the x component is over here. I can use those two components to find out what the measure of this angle here is. And the reason I want that angle right there is because since these two lines cross each other, then this angle is parallel, or not parallel, is congruent to this angle here. And so if I want how many degrees I need to rotate it from where it is, I need to know the measure of this angle here. So I have my difference on x, so my difference on x, and this is my difference on y. And this is a right triangle, which means I can be using one of the trig functions. So if you haven't learned this yet in school, this is just going to be a super weird introduction to it, but what I'm going to do is I'm going to use, if you guys remember your trig functions, you've got so, ka, and toa. And then in this triangle here, if I'm focusing on this angle, difference of x is the opposite, and difference of y is the adjacent. So I'm using O and A, which means I need to be focusing on t, which is tangent. So if I were to set this up, I would say that tangent of theta is equal to the difference of x divided by the difference of y. And this could cause a problem here in a second. I'm going to show you how we can fix that. So that's what the tangent of theta is. But that just gives you the value of the tangent and using two things we already have. So we already know what the value of the tangent is. We want to know what the angle is. So to find out what the angle is, you use something called the inverse tangent or the arctangent. And so if I were to do arctangent of both sides, arctangent essentially cancels out tangent, leaving it with theta equal to the arctangent. I'm going to write that as a tan. The arctangent of the difference on x divided by the difference on y. And that's going to be our angle theta. So I want to be able to find this angle here because this angle is going to be congruent to that angle. Okay, so let's show you how that looks in Unity. Quick run through of trigonometry. All right, so in here, what I want to do is I want to first find out what the difference on x is. So I'm just going to say float, and I'm making this inside the method so that it's local. I don't need to use it anywhere else. Same thing with the temp mouse position. It's a local variable. I don't need to use anywhere else. I'm going to call this float difference on x, and that's equal to the mouse start position dot x minus temp mouse position dot x. Then I need to know the difference on y. So float difference on y is equal to, I misspelled float there. Difference on y is equal to mouse start position dot y minus, ooh, good board. It's supposed to be a minus, okay, minus temp mouse position dot y. So I've created two different floats, one for the difference on x and the difference of y, and those represent the two sides of that right triangle that get created when you drag the mouse on screen. Okay, so the next thing we're going to do is we're going to find the angle in between them. And so to find the angle, I'm going to say that float theta, and if you haven't covered this in your math class yet, theta is just a Greek way to reference the angle. Instead of calling it like angle x, we call it angle theta. So float theta is going to be equal to mathf dot atan. Now, something about atan means that we're going to have to switch something here really quickly. So atan is arctangent, and this, They both have the same problem. Okay, so the summary here, it's float atan, and then you need to have a float inside, and then it returns the arctangent of f, the angle in radians, whose tangent is f. Angle in radians. And again, if you haven't taken enough math, you haven't taken Algebra 2, you might not know what radians are. Radians are another way of measuring an angle that doesn't use degrees. It's older, and some people think it's better than using degrees, but it can be very confusing if you've never seen it before. I'm not going to teach you about degrees today. Instead, I'll just show you how we can change that back to degrees. So we're going to say mathf.atan. And then what we're going to find the arctangent of is the difference of x divided by the difference of y, opposite over adjacent. Now, there's a problem that can come up from this, and we'll address that in a second. Now, like I said, this gives you back a radian measurement. We want it in degrees. So to turn it into degrees, there's a function built into Unity that automatically changes radian measures to degree measures. And that's called mathf.rad2degree. So you can change degrees to radians, and you can choose radians to degrees. We want to go from radians to degrees. You don't have to do a function with this. It's just actually a value. If you've taken Algebra 2, your teacher should have taught you how to change from radians to degrees. This is just that value. It's pi over 180. I mean, other way around, 180 over pi. Okay. And so now we're going to say that the arrow has an angle equal to the opposite. And I'll show you why it needs to be opposite in a second. So we're going to take the arrow, so arrow dot, and we want to access its rotation. So if we look back in Unity, we're going to need the transform, which is where rotation is. And then we want to change one of these three values, either the x, the y, or the z value. Now, this is really unintuitive to understand at first, but so x is left and right, y is up and down, z is towards the camera or away from the camera. So if I change the x value here of the rotation, you won't notice any changes. If I change the y value of the rotation, you won't notice any changes. So if I rotate it, well, you did that time, but usually you won't. The reason why is the axis that we're rotating on is coming towards the camera, and we want to rotate about that, like kind of like it's a hinge on a door. So what we want is we want the z value to be changing. But if you'll notice, I wanted 45 degrees to be here. 45 degrees is over here for some reason. So that means I'm going to have it be negative of whatever I expect it should be. So let's go back in to MonoDevelop. I'm going to do arrow.transform.rotation, which is, like I said, we've got the arrow object, here's its transform, and here's its rotation. We're going to say that this is equal to. Now, Unity does another weird thing, aside from returning measures of degrees and radians. It also doesn't allow you to just use a vector to set your rotation unless you do something else to it first. Unity uses something called quaternions, which I would be very surprised if any of you have heard of in your math time if you haven't already taken programming. For now, just know that a quaternion isn't an angle, and we have to change it into an angle. So to do that, we're going to do quaternion.Euler. There's a mathematician who came up with those and many other things. And then what we want to do is now we can just pass in a vector 3 that's an Euler vector. I want to do 0 degrees on the x-axis, 0 degrees on the y-axis, and I want the number of degrees on the z-axis to be the opposite of the angle that we just found. So I'm going to do negative theta. Okay, so I'm going to save this really quickly, and I'll jump into Unity here. And if I hit play, I'll let it think first. I'm a little too rushed. If I hit play, then if I click and oh, I didn't. I did not set that to something. Okay, so a couple things here. I'll go to the ball, and I didn't set the arrow to be something, so I need to do that right now. So I'll just grab the arrow here, and put it right there, or I could have done the circle selector and chosen the arrow from the objects in the scene. Okay, so I'm going to hit play. Okay, so there's a problem here. There's a red that was thrown, but for the most part right now it looks good. Our blue line is kind of switching wherever we go, but if I go up, it does this weird thing. That's bad. So I go up, and then it kind of flip-flops. We don't want that. But for the most part, it's fine. However, I did get an error down there. So let's take a look at what the error is. If you want to be able to see these errors better, you can either just click on them, and this console window comes up, or you can go up to Window and choose Console down here at the bottom. I'm going to dock my console next to my game view because I might need to use it a bunch. So this says, assertion failed on expression. Compare approximately square root magnitude result 1.0f. Unity engine.quaternion.euler single. And then it tells you where that came from. It says it came from ball controller update, line 29, and then also from mouse dragged in ball controller, line 50. It's really the line 50 that's the problem. And there's no problems with how it's coded. What there is a problem with, though, however, is another math lesson. Okay, so because degree theta here is equal to the arctangent of the difference of x and the difference of y, what happens if you say you start clicking here and then you drag your mouse straight over, so there's no difference on y. That would make the difference on y equal to 0, which is really bad because you cannot divide by 0. The difference of x divided by the difference of 0 creates a specific logic error in Unity, and Unity knows enough to protect itself from anything that would cause a division by 0, which is why I got that error. So we need to make sure that the difference of y can never be 0. Also, however, there's no reason I can possibly think of that someone would tap down and then pull up because they want the ball to go down, because as soon as the ball touches the ground, it stops moving. So we don't just want it to not be 0. We want it to never be 0 or less than 0. And that'll fix this error that we just had. So if I go back in here, before I find the degree, or before I find out what theta is, before I change that into degrees, when I find out what difference of y is, I'm going to put a little extra comment in here in between these two, and it needs to go in between these two. If it goes anywhere else in your mouse drag method, you're going to get that error, or no, yeah, you super will get that error, and then your arrow also won't act the way we want it to. So I'm going to add an if statement. So I'm going to say if difference on y is less than or equal to 0, then I want to change it. And I want to change it to just a small value. I'm going to say that difference y, nope, not x, y, is equal to 0.01f. And the f is there because it's a floating value, meaning it can be decimals and fractions. If you don't put the f there, Unity freaks out sometimes. So what I'm doing here is did drag is true, that's from last time. I'm setting the arrow active. I am finding out what the temporary mouse position is. I'm setting I'm finding the difference between the mouse starting position and the temporary mouse position, which will change. And I can keep accessing this because the update method is going to keep coming in here so long as I'm dragging. I'm going to find the difference on y. And then if that difference on y is less than or equal to 0, I'm going to set it to be 0.01. And then that happens so that my theta here doesn't return a division by 0 error. And that's going to be right here. Okay, so now the next thing I want to do is when I release the mouse, I want the arrow to go away. So I want to do arrow dot and then set active is how we made it active. And then this time, instead of telling it to be true, we're going to tell it to be false. So we want it to go away. There's one more thing we want to add here with this video, but let's just test this out really quickly. So Unity's going to think a little bit. This error will go away when I play it because I have clear on play ticked. So if I go to game, I hit play. Okay. So now if I go up, it doesn't go up, it just goes straight over. And if I go, so if I'm pulling like this, you can kind of control where it goes. That's still really thin. I definitely want to make that thicker. Okay, so yeah, let's make my line renderer thicker really quickly here. I'm going to set it to 0.1, but then I want this to be up here, this to be up here. I don't care if it's coming out of the ball, it's not a big deal. Let's try that now so that you can see it better. That's better. Okay, cool. Now I don't have it so that it gets longer the farther away you go. That's something we can add later. That's kind of a flash thing. It's not necessary. So, okay. It's already feeling kind of good, I think. Okay, so now what we want to do is there's an error here, and it's not a coding error. It's an error in logic and or design. So if I just click somewhere, now the ball is uninteractable, but it didn't go anywhere. It didn't make any movement. So I want to make sure that if you just tap the screen and then don't drag, it doesn't make you lose your turn or cause the game to freak out. So what I'm going to do here is where I'm checking the ball velocity, but before I'm turning things false, I'm going to add another if statement. I'm going to check to see what the ball velocity is. So I'm going to say if ball.velocity, and I want to see if it's equal to nothing, meaning the ball isn't moving at all. So if the ball isn't moving, we want to not take away that person's turn. So we'll do if ball.velocity is equal to. So in coding, you can use a single equal sign, and that changes the value of something. So like here, I took mouse end position and I changed its value to be camera.main.screen.world.point. Here, I changed the value of ball velocity x. I changed the value of ball velocity y. In an if statement, you don't want to change the values. You want to check if a value is equal to something. And so programmers decided that when you're checking a value, you use a double equal sign, and when you're changing a value, you use a single equal sign. So I want to see if the ball's velocity is equal to vector2.0, which is just, I don't want to do that, which is just 0, 0. So if the ball's velocity is 0 on the x-axis, 0 on the y-axis, then I'm going to return, which just means to break out of this method before I turn can interact false. So I'm going to save that really quickly. I'll pop back into Unity, let it think for a second. Okay, cool. And now, so if I just click, it doesn't take away your turn. One more thing too, the game starts with the arrow on. I want to turn the arrow off in the hierarchy. So it's kind of, I mean, they're all gray, but this is more grayed out. So now, if I click, but don't move, then it doesn't take away your turn. Okay, cool. So we added an arrow to the ball. Next time, we're going to make it so that when the ball hits the ground again, it's going to stop. So if you learned something, feel free to give me a like. If you have any questions at all, please list them in the comments, and have a great day.